In this video, we're going to review how to solve an equation for x. So let's take, for example, the following equation. So you have x over 24 is equal to 11 over 18. Okay. So now here's the thing about solving for x. So you have a few different objectives. Okay. So your main objective out here is to isolate x. What that means is you need to find a way to get x onto one side of the equation by itself. Okay, so x needs to be by itself. Okay, and the way you do that is you have to undo. So you have to undo whatever has been done to x. So the way you undo is if there, let's say for example, in this particular case, the cases that we're going to see is we're basically going to undo either multiplication or division. Okay, so if you have to undo multiplication, then you divide. Okay, so let me write that properly. Undo multiplication by dividing. Okay, and you would undo division by multiplying. Okay, and the third thing to keep in mind is whatever you do on one side has to be done to the other side. Okay, so do the same things to both sides. Now let me try to explain what I mean by this. So the way equations works is equations are more like kids. Okay, so let's say you have two children. Okay, you have two children, child one and then child two. Well, if you buy a lollipop for one kid, or if you buy a popsicle for one kid, you can't just give it to one kid and leave the other kid staring. You got to buy a popsicle for both kids, okay? So if you think of the two kids standing on two sides of the equation, whatever you do, if you buy a popsicle for or a lollipop, let's say a nice little swirly thing for this kid, you got to do the same exact thing for the other kid, okay? So that's how equations work. Whatever you do to one side, you do to the other side. I like to call it the popsicle effect or the lollipop effect. You can choose what you want to call it, okay? Okay, so let's go ahead and apply all of this to this equation. So out here we have x divided by 24 is equal to 11 by 18. So we have to undo the 24 in order to isolate the x. So since x is divided by 24, we undo the division by multiplying. So we're going to multiply both sides by 24. And you could just multiply it, just put the 24 out here if you want, or if you want to make it easier, just put the 24 over 1, and then you have a nice fraction which you can reduce, which is easier to see how you can reduce basically. So we'll do this now because of the popsicle effect. We're going to give a popsicle to the other kid on the other side. So that's 24 over 1. And now we can see that these two 24s get cancelled out, leaving behind 1. So the left side simplifies to x over 1, which is equal to, and then the right side, now before you go ahead and multiply, remember, we got to reduce before multiplying. So in this particular case, 18, you can, if you take 18 and divide it by 6, you get 3. You take 24 and divide it by 6, you get 4. Okay, and that's the extent to which you can do it. So then you have 11 times 4 over 3. So then the left side becomes x is equal to, and the right side becomes 44 over 3. So that's your answer. Okay, so you solve for x. Now this doesn't look like a very pretty solution, but it is the correct solution. Now, as you can see out here, you actually end up getting an improper fraction, basically because the numerator is bigger than the denominator. So you have the choice to change this to a mixed number. So if you want to change it to a mixed number, you have to divide the 44 by 3. So what you can do is just, if you try to divide 44 by 3, let's go ahead and try to do it using long division out here. So put the 3 out there. If we divide the 44 by 3, 3 times 1 is 3. Subtract the 4 minus 3 gives you 1, and then I drop the 4 down. So 3 times 4 is 12. subtract, and I have 2 left as a remainder. Okay, so the answer to this as a mixed number would be, I write the 14 out there, okay, and then the remainder, which is the 2, I put that over the 3, okay, and therefore you have 2 ways to express this answer, either as a improper fraction or as a mixed number. All right, you could express it as a decimal as well, but let's just keep it simple. Choose which one how you want to represent it, okay? Let's take a look at another example. So let's say you have 7 divided by x is equal to 18 divided by 21. Okay, now the thing about this problem out here is, before you can isolate x, you need to understand that x is sitting at the bottom of a fraction. So the first thing you want to do is you want to get x to jump from the bottom to the top. So the way you do it is you just flip the whole fraction on its head. So if I do that, I get x over 7 is equal to 21 over 18. Notice carefully, I did not just flip this side, I flipped this side as well, okay? So when I do that, now I'm going to undo the 7 by multiplying both sides with 7 over 1. There you go. So the left side simplifies to x, and the right side I can simplify that further by just going ahead and reducing the 21 and the 18. So that's what 3 times 6 is 18 and 3 times 7 is 21. So x is equal to 49. 7 times 7 is 49 over 6. Again, I have an improper fraction. I could change that to a mixed number. So if I do my long division out here, well, 6 times 8 is 48, leaving behind 1 as a remainder. So therefore, this could be written as 8 and 1 over 6. All right, feel free to pause the video if you want to follow along, and you could solve the problems, try to solve the problem by yourself without looking at the solution, and then you can unpause the video and watch the solution. Let's do another one. This time I have 5 divided by 8 is equal to x divided by 20. Okay, so now I have x on the right hand side of the equation, and that's totally fine. We'll just keep the x out there and try to get rid of the 20 from here. So we multiply. I'm just going to go ahead and write this down. I'm just going to copy it and put it down here. Or maybe what I'll do is, I won't do that. I'm just going to place this a little here so we have space. Multiply both sides with 20 over 1. And that'll get rid of the 20 from the right hand side. So I have x is equal to, now I'm going to reduce the left hand side. So 4 times 2 is 8 and 4 times 5 is 20. That gives me 25 over 2. Excuse me. Again, in proper fraction, I can go ahead and change that to a mixed number. So 25 divided by 2, which is going to give me 2 times 1 is 2. Well, if I subtract that, it gives me 0. If I drop the 5 down, 2 times 2 is 4. If I subtract them out, it gives me 1. So that makes my answer 12 and 1/2, okay, as a mixed number. Let's do another one. Notice carefully, I'm just showing you different variations of how to solve for x, okay, what all the different forms you can see. 4 over 42 is equal to 150 over x. So now if I'm trying to get rid of the x, again, x is at the bottom, I'm going to flip the whole equation on its head. So that makes it 42 over 4 is equal to x over 150. You have to get the x on top, okay, before you can do anything. And then I'm going to get rid of the 150 by multiplying both sides with 150 over 1. Okay, so that becomes x. So x is equal to, and then I'm going to reduce the left hand side. So I'm going to cancel. I'm going to try to factor out the 42 and the 4. So 2 times 2 is 4, and 2 times 21 is 42. And then 2 goes into 150 75 times, okay? And so now it's a matter of just multiplying the 75 with 21, okay, which I can use my long multiplication method out here, 75 times 21. So 1 times 75 is 75. I put a 0 out here. 2 times 75 is 150. Drop the 5, 7, 5, 1. Okay, so x is equal to 1, 5, 7, 5. Okay, and that's pretty much what we are going to cover in this video. Thank you for watching.